Okay, this is Algebra 2, Lesson 6.3. We're adding, subtracting, and multiplying polynomials. And that's exactly what our goals are. We'll look at them in some real life problems as we go. Page 338 in the textbook. Okay, I'm going to show you two different ways, both horizontal and vertically, to add and subtract and multiply polynomials. Now, most of us, once you find one way that works, there's no reason to do it the other way. But I'll show you both ways just in case. When you add in polynomials, what you want to do is stack them with the like polynomials. Notice they're in columns. This first column is x to the third power here. Then it's x squared. Then it's x to the first power. And then it's the constant term that doesn't have anything. Once they're stacked like that, and remember, you can reorder them however you see fit. Once they're stacked that way, though, you simply add the coefficients, 2 plus 3, and get 5x to the third power, negative 3 and positive 2, and you get negative 1x squared. There's no reason to write in that 1, but if it was there where you can see it, negative 1x squared. 7 and negative 3 gives you 4x, and then negative 5, there's nothing to combine it with, so it's negative 5. Remember, don't think of it as adding and subtracting. We'll look at example 1 and example 2 that talks about adding and subtracting, but you can think of them as the same thing, because when you're combining like terms, and the fact that they have the same variable raised to the same exponent makes them like terms, you just put them together. You can think of them as the same thing. The next method is the horizontal method. Most of us, even though it looks harder, most of us will do it this way because this is a way we're more comfortable doing it. You put the like terms together here. So you have x to the third power plus negative 6x to the third power. So that's like 1 minus 6. 1 minus 6 gives you negative 5x to the third power. Okay, I was just a little confused with this line right here. It just writes everything next to it. It just puts all the things that are like terms side by side to where you can see them a little bit easier. So right here, x to the third minus 6x to the third power. The next one is 6x squared, and it's positive. I'm sorry, 6x. Now notice that's x to the first power. Okay, you always want to count down with your exponents or with your degrees. So you wouldn't do 6x to the first power. You would go to where it says x squared. There's only one x squared term. So notice the next one, the only x squared term is here, positive 2x squared. It's by itself. Then x to the first power comes next, 6x plus negative 9x, which is the same thing as 6 minus 9. And then your constant terms are last in this case, 4, positive 4, plus a negative 2, which means 4 minus 2. So this line, even though it looks really long on the next line, it's all of them written next to each other. You'll notice with these polynomials, these problems will look really long as you're doing them, and they'll get significantly shorter after a step or two. So when you combine all of these terms, 1x to the third minus 6x to the third, you get 5x to the third. Well, there's only one x squared, so it's simply plus 2x squared. Then when you combine 6x and negative 9x, you get negative 3x. And then 4 minus 2, you get 2. And again, none of those terms can be combined because they're not like terms. Remember, you can multiply and divide things that are not like terms, and that's when you add and subtract the exponents respectively. But when you're combining the like terms, they have to be the same variable raised to the same exponent, which none of these are. So this is written in standard form. You always write them with the largest degree. And when I say that term degree, the largest degree means the biggest exponent always goes first. That one goes first, and then you count down with your exponents. X squared is next, then x to the first power, followed by the constant term at the end. Okay, so either off to the side or on the back, do this problem, and do it vertically like this one says. 5x squared plus x minus 7 minus 3x squared minus 6x minus 1. Take about 30 seconds on that one. And again, this is nice and neat and stacked for you. X squareds on top of each other, x to the first power in constant terms. So all you do is put the coefficients together. 5 minus 3 gives you 2x squared. You don't have to do anything with the x squared. 1x and negative 6x gives you negative 5x. And negative 7 and negative 1 gives you negative 8. That's all you can do with that one because none of those are like terms. So that was a vertical version. Do this one horizontally. X to the fourth power plus 2x to the third plus 8 plus 2x squared minus 9. Take about 30 seconds on that one. Since you're not going to be doing this with different colors like I do, what I see students do sometime to make sure they put all the like terms together is they'll do x to the fourth power plus 2x to the fourth power. Both of those are x to the fourth. So you put 1 plus 2 together and you get 3x to the fourth power. The next degree is x to the third power. So what I'll see students do is they'll underline it with two lines like that. So plus 2x to the third power. Notice there isn't an x to the third power on the next one. So it's simply plus 2x to the third power. The next degree, there is no x squared, and there is no x to the first power. So the next degree is the constant term, and they'll put three lines under that one. So 8 plus a negative 9, which means 8 minus 9, which is negative 1. So 3x to the fourth power plus 2x to the third minus 1. That is adding polynomials both vertically and horizontally. I'm going to ask you on the test to do it both ways, but I won't be able to tell which method you use. So if you prefer one of these methods, which you will, use the method you feel better with, and you'll have more success doing it with that one. Okay, subtracting is the same thing as adding. It's like I always tell you, don't think of them as subtracting and adding. Just think of it as combining. It's the same. It's both positive and negative. Here is subtracting vertically. Now notice this negative out front. I heard somebody talking about this while you guys were doing it. Notice that negative out front. What that does is it changes all of the signs. It's like distributing negative 1 to every term. Negative 1 times 5x to the third power gives you negative 5x to the third power. Negative 1 times negative x squared gives you a positive x squared. Negative 1 times x is negative x, and negative 1 times negative 6 is positive 6. So notice off to the right where everything's written in red, all of the signs are switched. Then you just combine them like we just did on example number 1. They're still stacked nice and neatly for you, x to the third, x squared, x to the first power, and then constant terms. So you combine 7 and negative 5, and you get 2x to the third, 4 and 1, and get 5x squared, negative 1 and negative 1. Notice it says negative 2x, and negative 4 and 6, and you get positive 2. And again, that's combined. Most people, even though this method looks shorter, most people don't add and subtract polynomials this way because most of the time it involves another step. Most of the time they're not stacked nice and neat like that for you. You have to make them stacked, which creates an additional step. So most of us prefer this method, the horizontal method. Again, though, notice 3x to the fourth power plus 9x to the third plus 2 minus 2x to the fourth plus 6x to the third plus 2x minus 4. Notice the biggest part about this one is the negative or the minus in the middle. What that's going to do is it's going to change all of the signs. And you can see on this line that's written in red, all of those signs are opposite of what they were originally. It's negative 2x to the fourth, negative 6x to the third, negative 2x, and positive 4. But again, what a lot of people do is they'll say 3x to the fourth minus 2x to the fourth. And I'll put that's on the next line right here. 3x to the fourth minus 2x to the fourth is 1x to the fourth. The next degree is x to the third, 9x to the third minus 6x to the third. 9 minus 6 is 3x to the third. The next degree, notice there is no x squared or x to the first power in that first polynomial. The next degree is this one here, 2x. Now make sure at this point you don't make this mistake. It's positive 2x, but there's a negative in front of that parentheses, which makes it minus 2x. And then the last degree is your constant term, 2 minus a negative 4. And remember, anytime you have 2 minus a negative something, that turns into plus a positive, and that's why it's plus 6. And when those, you can't put any of those together because none of those are like terms. Again, on the back or right there in the margin, let's do this one. 3x to the third plus 8x squared minus x minus 5 minus 5x to the third minus x squared. Notice that blank there, plus 17. Take about 30 seconds on that one. Okay, again, all of these are nice and stacked, even with that blank, because there is no x to the first power. There's no x to the first power degree on that second one. But again, this is minus for all of them. So 3x squared minus 5x squared is going to give you negative 2x. I'm saying squared. Negative 2x to the third. Excuse me. 8x squared. Now it's minus a negative. Minus a negative. This is an easy place to make a mistake. This is plus a positive. So this is going to be positive 9x squared. It might help you tremendously to write out this entire line with opposite signs to where you don't make a mistake. Negative x plus, it'll be minus nothing. So now this one's simply going to be negative x. And negative 5 minus 17 is going to be negative 22. So that's the vertical method of combining your like terms. Negative 2x cubed plus 9x squared minus x minus 22. And again, let's do the horizontal method. 9x to the fourth minus 12x to the third plus x squared minus 8 minus 3x to the fourth minus 12x to the third minus x. Take 30 seconds on that one. Again, another thing, since you guys aren't using different colors like I am, another thing besides underlining that I see students do is they draw different shapes around the ones that they're dealing with. So for the first degree, the largest degree is x to the fourth power. So this first one, 9x to the fourth minus 3x to the fourth. So 9 minus 3 is 6x to the fourth. The next degree is x to the third. This one, a different shape beside a circle, is, let's say, a rectangle. Negative 12x to the third, again, minus negative 12x to the third. Minus a negative, remember what that means. That means plus a positive. So negative 12 plus 12 is how many x's to the third? 0. That's right. So it'll be plus 0x to the third. I'm going to write that just for a second. There's no reason to write that. I'm just going to write it just for a second, just to where we can explain that for a second. So plus 0x to the third. The next one is x squared. Notice there's no x squared in the second polynomial. So another shape for that one maybe is a triangle. I know that looks goofy, but it helps people to do that. So plus x squared, since there is no x squared in the second polynomial. The next one is x to the first power. Let's say we have to underline that one. But again, there's none in the left one on the first polynomial. But it's minus a negative x, which means plus a positive x. And then the last one is negative 8. It's a constant. There's nothing on the right-hand side, so minus 8. This is subtracting the horizontal method. 6x to the fourth plus, and again, there's no reason to write 0x to the third power. So we would simply leave this out, and it would be 6x to the fourth plus x squared plus x minus 8. So that's adding and subtracting polynomials. Really simple as long as you remember that you can only combine like terms. Here is multiplying polynomials vertically. Okay, what this is we're multiplying everything in this top trinomial x squared minus x plus 3. We're multiplying everything by 2. So 2, it's just like multiplying, just like you've always learned. 2 times 3 is 6. 2 times negative x is negative 2x. So it's this times this. This times this is negative 2x. And this times this is positive 2x squared. And then on the next line, you're still leaving this placeholder space you've always left when you do two lines, when you multiply, just like multiplying 12 times 11. You do 1 times 2 and 1 times 1, and then you leave this space. And then you do 1 times 2 and 1 times 1 again. Same thing, except this time we're going to multiply instead of 2 times all of those, you're going to multiply x times all of those. So x times 3 is 3x. X times negative x is going to be a negative. Remember, when you multiply the same bases like x and x, you add the exponents 1 and 1 to get x squared. So that's why it says negative x squared. And then x times x squared, again, positive, since it's both of them are positive, you add the exponents 1 and 2 to get x to the third power. Notice now everything is set up nice and neat for the vertical method. Just like we just did a minute ago, adding and subtracting, it's vertical. There's only one x to the third power, so it's simply x to the third power. 2x squared minus x squared, 2 minus 1 is plus x squared. Negative 2x plus 3x is positive x, and there's only one constant, plus 6. So then you combine your like terms. That is multiplying vertically. On the back or on the side, let's do this last problem today, and then we'll do the rest tomorrow. 4x squared plus x minus 5 times 2x plus 1. Let's take about 45 seconds on this one. Okay, the first thing you want to do is multiply 1 times everything. Times negative 5 is negative 5. Times x is positive x or plus x. Times 4x squared is 4x squared. One's easy to multiply by. Then multiply 2x times everything. Remember your placeholder here. If you need to write in a 0, it's okay. 2x times negative 5 is negative 10x. 2x times x is positive 2x squared. And 2x times 4x squared is 8x to the third power. Notice everything is set up nice and neat vertically to combine your like terms. 8x to the third plus 6x squared. Plus 1 minus 10 is negative 9x minus 5. And we'll finish up the rest tomorrow.